Hello everyone. In this video we are going to look at the lambda functions, what they are and where it is used in C++. So the lambda functions are used for defining a function where it is invoked. So basically you have few lines of code and where it is executed exactly in the same line, but usually if it is a function, your function is defined somewhere and you call it somewhere, but this one is lambda function is a define a function where it is invoked with the parameter list. So this is a basic usage of this. So let us look at the format of it. So the format of the lambda function is it starts with the capture clause and followed by it starts with the capture clause followed by a parameter list and followed by a function body and then a optional parameter value. So we are going to look into this details by just defining various examples for it. So let me do a first example, and in this example I'm just going to use exactly the lambda function. So I mean in a sense in a simple format. So simple lambda function, so that I can understand the contents in it and the format of it. So simple lambda function is my first example, and as I said, the lambda function should have a capture clause and followed by the parameter list and followed by a function body. So this are all three, but in here the capture clause can be empty, but still you need to define that brackets here. I'm for the first function as an example, or the first one, I'm going to use only the function body and remaining things are empty here. So let me send something out like hello world. So let me call it as from lambda C++ function. I call this like this, and then end the line here, and then I finish it here. So this is my lambda function already, and to use this lambda function, let me assign this function to a function called func. I just assign it, and then I just call this function. So sorry, I need to finish this lambda function because lambda, as I said, it's defined where it is invoked, so you just need to finish this so that it's already a compiled compiled statement. So now I call the func which has been a lambda function here, yeah, and let me build this and run this. So I just go and build it. So for building I'm just using standard C++ 11.1 and I'm just going to build this lambda.cpp, and then I run the out file. So it says lambda from lambda C++ function. Okay, yes, that's perfect. So this is the first example, guys. So to use the lambda function, what you need is a capture class, parameter list and a function body, and ends with the semicolon, so that your lambda function completes here basically. Okay, so this is our first example. Let's move on. Let's try to understand a bit more concepts of lambda functions until all the new features, even C++ 14 features as well, we'll try to understand in a simple example like this. So we'll keep it simple. So let us go to the next example. I comment out the first one so that we can refer it later if you want. So now I'm going to the next example. So the second example, I'm trying to use the parameters. So I'm going to pass some parameters and I'm going to use this parameters values inside the function. So let me as I said, the parameter is the second set of the values. I'm still not using the capture class yet. I'm going to use it shortly. Okay, so just for my references, let us keep this here. So as I said, this is capture class, and next one is parameter list, and the next one is the function body. So because this is very important, guys, because this is what the lambda function is. So if you are asked to create a lambda function, if you know this basic format, then you are there already. So, and then this one is optional values of the variables. So I call it as optional because you don't need to pass this every time. So in this case I didn't do that. So okay, now I come to the second one. So I'm passing this two variables here, int a and int b, and I'm going to use this int a and int b here. So I say a plus b is a plus b here, and then I'm going to, so instead of passing the keeping that in the function, I just keep only the lambda function here, and then let's assume this values I'm directly passing it inside, so I don't need function here. So basically in this example, even you are not assigning this function to as a new function and you are invoking this function, but instead you just define a function and that's it, and it is an executable statement, and it will be what it is, like a function, but still it is inside the main code, your function, everything is defined. So that's the beauty of this lambda function is. So let us just build it and check. So now so a plus b is 35. So basically this statement is executed inside, and this is what exactly lambda function's feature is. So you just define and invoke it at the same time. Okay, so let us move on and let us try to comment this out, and then we go to the next example of it. So let me call it as example 3 here. So in this example, I'm going to return some values in this lambda function. So let me return some values. Okay, so for that I'm still going to have the capture class, but still I'm not passing any value yet. So I'm going to pass two variables here, int a and int b, and then my lambda function starts. And in the lambda function, in this example, we are going to just return the values. So I just, okay, and then I need to finish this lambda function here. I just return the values. Okay, so now because it is returning the value, I just the returned value, I just assign it to a sum here, and then I just now the lambda function is completed here. So in sum, so let me check. So we just have so int sum equals int a, int b, and then I just return these values. Okay, so the only issue here is I have not passed the values yet. So let me pass this values, a fixed value here. So basically these values I passed them already, because since I assigned this to a sum, I need to pass these values as well. Okay, so now I will just print out this sum here, so that we just try to use this lambda function in the line, and then let me just try to build it and run it here. Okay, so sum is 25. This is our third example, guys. So here we have used this lambda function which is returning some value. So now we have seen the capability of a lambda function which can return some values. Now we will try to use the capture clause, because this is very important in a lambda function, where you can pass the values. If say for example, if you have some variables outside the function and you want to use inside the lambda function, that is where you could use them. So let us try to go to a fourth example. So this third example, we said we want to return value, and we finished the third one, and then now I'm going to the fourth one. Let me call it as example 4 here, and the example 4 is capture class. So let us use the capture class here. So for that, I will have two variables, and the variables, let us assume, say a is say 20, and then I have int b is 30. So I have two variables here, and these two variables I'm going to use it in the lambda function. So if you wanted to use it in the lambda function, this is where your capture class comes into effect. So I'm going to pass this a and b here, and then my parameter list is empty, and then I just have a function, and where this function, inside the function, I'm going to use C plus C and D here. So I just going to print send C plus D. I'm going to print this value. So and I'm going to finish this. So now, oh sorry, it's not a C plus, let me try to use a plus b here. So this a plus b values, I'm going to print them inside. So now the here the a plus b inside the function body, you see, if we don't pass the a plus b here, inside the function body, the a plus b doesn't know, because the function a plus b is outside this lambda functions. So whatever the values inside are everything local. So if you don't define it inside or pass the parameter inside, the function will not know what the values are, and that is what is happening here. So if you wanted to pass those values inside the lambda function, you just pass the values here. So, and that is where the capture class is being useful. Okay, so let me assign this function to auto func, and then let me call this function. And if I call this function and then I build it, and I should be able to get the output of a plus b is 50, because a plus b, a is 20 here and b is 30. So basically you are able to pass these values inside the lambda function, but only it was possible because of this capture class here, otherwise you wouldn't be able to pass it. So this is how you can pass the values here. But I want to show you what happens if these values are changed outside, whether this is being passed to the value inside or not. So for that, I'm going to create a loop here, and I'm going to loop this value through int I is 0 10 times here. 10 times I'm going to iterate this loop, and inside this loop I'm going to call this function, and I am going to increment a and b as well, and b I just maybe increment with 5, for example. So now if I run this, so okay, so this is going to print this. So basically this loop is going to be iterated 10 times calling this function, and then it's going to increment a with 1 and b 5. So So that means what should happen is A and B are 20 and 30. So first time it should print 50 and second time it should be 56 and so on. So that is my expectations because I incremented these values here. So let me build this, and then when I run this, you can see A plus B is always 50. So what's going on here? I think this is the beauty of this lambda function is basically all these values here are local. So and this value, whatever you pass it inside to the A and B, is passed by value, not by reference. So that means it is passed 1. So whenever you call it first time, it passes that value, and when you are keep calling them, it keeps that value local, and it won't take the effect of whatever the values are being changed outside. So if you wanted the values to be changed inside, and that is when you should use the call by reference. So the call by reference is by the reference like this. So for example, B here will be changed if you change the values outside. So let me build this again. So I call this out. Now you could see B is incremented every 5. So that means the B value is taken into effect whatever we are changing outside here. So that is where call by reference is important. So in the capture class, you could either pass the value by the value or pass it as a reference. So if you pass it as a reference, if you change it outside, that will be taken into effect inside as well. So, and then now let me just change the A value as well, just to check, and you could see, so A value also is being incremented because A is incremented once and then B is incremented 5 times. So, and you could see that value is being, whatever the values are changed, is being taken into effect. Otherwise, if you pass that without the reference, then it will be whatever the changes outside will not be used inside. So this is change by reference, pass by reference, and there is a few more. Say for example, if you wanted to pass, so if you have few more variables and if you wanted to pass every values inside, then you could use it as equal sign. So the equal sign, what it does is, whatever the values outside is being passed inside the function, but it's passed as by value. And let me run this now, and you could see that value didn't change, but it is still able to find. So whatever the values outside is being able to use it inside by using the equal sign here. And now if I use the reference sign here, what happens is all the values are used by reference. So you don't need to specify A, B, or if you have 5 variables, you don't need to specify all of them. Instead, all the values outside are passed to inside the inside the lambda function. So now let me try to build it, and it should able to build, and it should able to pass the values by reference, because both A and B values are passed by reference in this case. So that's exactly what the capture class, guys. So the capture class is used to pass the values outside of the function to the lambda function inside. So this is exactly what it is. And now I'm going to go to the next feature of the lambda, which generalized lambda. So this generalized lambda is being introduced from C++ 14 onwards. So because in C++ 11 this feature is not there, so we call it as generalized lambda. So let us define a generalized lambda, or first let me define without generalized lambda, and I will tell you how it can be used in what is the difference in the generalized lambda. So for that I just define a lambda function. So I just call it as int a and int b. So we just use the same variable as we used in the other examples, and then I just finish this lambda function here, and then let me just return this sum of these values a plus b here. So and then I pass this to int sum here, and then so for this so if I wanted to use the generalized function, so what happens is, say for example, if I wanted to so now the sum is assigned here, and then now if I wanted to pass the sum function with a value called so this is basically, so let me just take this example here. So I'm not assigning this to sum, I just assign to auto here. So let me consider this. So now if I so if I just see out this with value say an integer value 1 and 6, so even though it is an integer, say I could very well use this sum with 1 6, or I may pass this value as floating point values here. So it is very well possible, but on C++, so okay, oh sorry, okay, so let me take this from integer first, so that at least I will just explain you what it is doing with the integer. So now in C++ 11 the lambda functions, the parameter list didn't accept auto variables, and it started accepting the auto variables only from C++ 14, because to support this generalized lambda. So what is generalized lambda is, you could use the lambda function in a template so that any auto variables can be passed in, so that you can use it as a generalized lambda function. So here for example, so this function I can just very well build it in a C++ 11. So let me try to build it, and I can now check the output, and it is very well working, setting this output. Now if I wanted to pass the same with the floating point value, say 1.2 and 6.2, I can't use this because I defined this variable as integer here, and if I try to build this, so it could still build, but the output will be on the second one, it still prints out as 7. Is because we pass this value as integer, so it is not accepting a floating point values here. So this is where the generalized lambda comes in. So the generalized lambda can accept auto function, auto variables here. So if you use the auto variables, you could very well pass a different data types to this lambda function, so that it can work on any data type. But if I try to build them on the C++ 11, you can't build them, is because this feature were not available in C++ 11, so it is available only in C++ 14. So for that I need to build this code with the C++ 14 feature, and then if I run this, I get exactly this for this second option, for example, I get this value as 7.4. So So this is a C++ feature which is implementing this generalized lambda. So if you wanted to pass some variables with auto type to pass it on any variable, so that you can use it in a template functions or any other generalized lambda. That feature is available only in C++ 11 but 14, sorry. Otherwise the rest of the features are available in C++ 11. So this is it, guys. I think we got a fairly good understanding. So we just define the lambda function, and then we try to use the parameters, and we try to use a return value, and then we use the capture class, and then we just found a difference in about the generalized lambda, where the feature is implemented in C++ 14. So I hope this session was useful for you to understand what the lambda function is and how to use it. And many thanks, guys, for tuning in. And I hope to see you in other C++ tutorials. Thanks a lot. Bye.